All right, today we're going to talk about lesson 3.7, absolute value equations and inequalities. Serena skates towards Darius and then passes him by. She skates at a constant speed of 20 feet per second. At what times is Serena 60 feet from Darius? Explain your reasoning. You can see right now she's 100 feet away. She's going 20 feet per second. When is she 60 feet from Darius? Pause this video, come up with an answer, and then restart. So after 1 second, she's gone 20 feet. Another second, she's gone 40 feet. After 40 feet, she's now 60 feet away. This is 60 feet. It should be straight, but then she could also be 60 feet on this side, right? So again, every 20 feet per second. So here's 20 feet. Here's another 20 feet. That's 2 seconds. So at 2 seconds, she's 60 feet. And then here's another 20 feet. That's 60. Here's 80. Here's 100. 20. 40, 60. So 2, 3, 4, 5, 6, 7. Here's 8 seconds. She's also. And so 2 and 8 seconds. So what are the solutions of the absolute value of x plus 2 equals 9? Well, when we're solving absolute value equations, what you want to do is get the absolute value sign by itself. So here we would subtract 2 from both sides of the equation. Once we subtract 2 from both sides, we get the absolute value of x equals 7. Now, what value of x, absolute value of x is equal to 7? Well, x in this case could be 7, because the absolute value of 7 is 7. But x could also be negative 7, because the absolute value of negative 7 is 7. Remember, absolute value is a distance from 0. Here's what it looks like on the number line, and we can see that negative 7 is 7 from 0, and positive 7 is 7 from 0. And so both negative 7 and positive 7 are 7 away from 0. So you try this one. What are the solutions of the absolute value of n minus 5 equal to negative 2? Pause the video, start it up when you're ready. Well, first we would add 5 to both sides. We'd get the absolute value of n equals 3. And what's 3 away from 0? Well, both positive 3 and negative 3. So to solve an equation in the form the absolute value of a equals b, where a represents variable expression and b is bigger than 0, then a is going to equal b and a is going to equal the opposite of b. Sometimes we have the situation like we just had. Here we're starting from 100 feet away. Your friend skates towards you and then passes you by, skating at 20 feet per second. Her distance would be given by the absolute value of 100 minus 20t. The question wants to know at what times is she 40 feet from you. So we could substitute 40 in for d, and when we do that we get 40 equals the absolute value of 100 minus 20t. Well, here we already have the absolute value sign on one side of the equation. But we know whatever's inside this absolute value sign, whatever this is in here, has to be 40 because the absolute value of 40 is 40. But we also know what's inside here could be negative 40 because the absolute value of negative 40 is also equal to 40. And so what's inside could be either one. So we set up two equations. One, 40 equals 100 minus 20t. But we also know it could be negative 40 is 100 minus 20t. We solve these two equations by subtracting 100 from both sides of the equations. And we get negative 60 equals negative 20t, or negative 140 equals negative 20t. Next step, divide by negative 20. That gives me 3 or 7. So the two times where my friend is going to be 40 feet from me is 3 seconds and 7 seconds. Now we're going to have you try one. Another friend's distance from you is d equals the absolute value of 80 minus 5t. First, what does the 80 in the equation represent? Your friend's starting distance, just like in the last one, only it was 100. Next, what does the 5 in the equation represent? Well, that's your friend's speed, just like in the last one, it was 20 feet per second. And then it says, at what times is she 60 feet from you? So we're going to represent 60. We're going to put that in for D. And so now I'm going to give you a moment to solve this. Please pause the video. Remember, whatever's in the absolute value sign has to be 60, or it can be negative 60, because the absolute value of 60 is 60, and the absolute value of negative 60 is 60. So we solve this by subtracting 80 and dividing by negative 5. So here's another one. What are the solutions of 3 equals the absolute value of 2x plus 9 plus 12 equal 10? Well, again, we want to get the absolute value sign by itself. So in order to do that, we probably should get rid of this positive 12. And we could do that by subtracting 12 from both sides. Next, we want to get the absolute value by itself, so we probably should get rid of this 3. It's being multiplied, so we'll divide both sides by 3. Now we have an absolute value, and so we're going to make it equal to negative 2/3 and also positive 2/3. We can go ahead and subtract 9, and then divide both sides by 2. And here we have the answer as negative 29/6 and negative 25/6. But what's wrong? There's a problem with these answers. Look right here. The absolute value of some value, absolute value, cannot be a negative. You can't take a distance and get a negative thing. So right here at this point, you can realize that we have made a mistake and that these answers are incorrect. We cannot have a negative value. So there are no solutions. Now it's your turn. Take this, pause the video, and solve it. So we could add 5 to both sides, and we realize right away we have the absolute value is a negative. We can't do that, so there's no solution. Now we can do the same thing with inequalities as we did with equations. The only difference here is when we make the absolute value of A equal B, and then we make the absolute value of A equal to the opposite of B, with inequalities, that opposite of B, because we're really kind of multiplying by a negative, we're going to have to invert the sign. So here we have the absolute value of 8n is greater than or equal to 24. So we're going to set 8n equal to 24, or greater than or equal to 24. And we're going to make 8n less than or equal to negative 24. Again, when we use the negative, we invert the sign. Now we can go ahead and divide by 8. And so we get n is greater than 3, or it's less than or equal to negative 3. This is an or statement because it's going in opposite directions. You try this one. The absolute value of 2x plus 4 is greater than or equal to 5. Pause the video until you're finished. So we would make 2x plus 4 greater than or equal to 5, and 2x plus 4 less than or equal to negative 5. We would subtract 4 and divide by 2. So here we have x is greater than or equal to a half, or less than negative 4 and a half. A company is making boxes of crackers that should weigh 213 grams. The quality control inspector randomly selects boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back. So what is the range of allowable weights for a box of crackers? We can do this without the inequality. We know that all I have to do is take 213, which is what we want, and we subtract 5, and we add 5, because it can be 5 grams on either side. But let's set up an inequality so that we can see how we can use what we're learning. We would say the weight of the new box minus what it should be has to be less than or equal to 5 grams. And because it's an absolute value, it could be a little bit more, 5 more, or 5 less. We would solve this by setting up W minus 213 is less than or equal to 5, and W minus 213 is greater than or equal to negative 5. Continue to solve by adding 213 to both sides, and we end up what we said. 213 minus 5 is 208, 213 plus 5 is 218. And we can write it as an and compound inequality. Your turn. Try this. A food manufacturer makes 32-ounce boxes of pasta. Not every box weighs exactly 32 ounces. The allowable difference is 5/100ths of an ounce. Write and solve an absolute value inequality to find the range of allowable weights. Again, this is possible without writing the inequality, but try it. Pause the video and then start. So hopefully you wrote W minus 32 is less than or equal to 5/100ths, the absolute value of W minus 32. Again, we can set up two inequalities, add 32 to both sides, and we have our inequality written as an and compound inequality. Okay, that's the lesson.